Generally, if you're alive, it's a good idea to move as much as you can in as many ways as you can. Here's an interesting movement called the gorilla walk, as performed by SiX. And it might look a little different, but it captures a sudden and fascinating moment in time. In that moment, it's about suspension of the lower body. But let's talk about the arms first, because they set up the motion. So the movement of the arms is interesting, but it's where they pause moving that's really interesting. You can see that the arms come forward, with the body lagging behind. This sets the spine into an extended position, and tilts the pelvis anterior compared to where it started and where it will end up again. Notice that the knees are hovering above the ground, not touching. The legs have to then come forward from this position without touching the ground, which means they have to be lifted sufficiently to clear that ground, which means the legs have to be held up by the trunk, which means the trunk has to be held up by the arms, which means that as the legs are coming forward, the arms and trunk are almost stationary. For the arms to hold the trunk in this position, it's a balance by loaded compression of their parallel surfaces, a subject we've covered a few times before. But as well, the arms hold through the muscular efforts of the upper girdle. Because this brief moment in time is not moving through a position, it's actually keeping things stationary, we want to contract many opposing muscles in the upper body at once, so that we can firmly hold the arm to the scapula to the thorax. This will be done through the biceps, the triceps, the deltoid, the rotator cuff, the rhomboids and trapezius, as well as the pec major minor in front. Once the upper body is secured, it has a stable base to pull the lower body forward. Now, this capacity of the trunk and abdominals to suspend the whole lower body is not entirely unique. It normally does this very regularly, one side at a time, when we walk. Because when we walk, the back leg, swinging forward, must be pulled by the hip flexors and supported by the pelvis and lumbar spine, which are held in a significant way by the abdominal muscles. So doing this both sides at the same time is certainly harder, but not improbable. If we slow this down, you can see a lot of the hip position remains relatively the same. So the main motion happening is that the pelvis tucks under, or a posterior tilt relative to the top of the pelvis being the technical term. And the lower limbs are attached to that pelvis, and so are pulled along with it, maintaining the height of the pelvis and allowing the feet to clear the ground. This requires a lot of abdominal muscle contraction. Let's flip the image and move the arms and legs to make it a little more obvious though. The rectus abdominis, being the most center abdominal muscle, can pull the pelvis up in front. More laterally, we can pull up the sides of the pelvis through both obliques. To maintain the legs in this position, we need the hip flexors. So as iliacus, rectus femoris. Rectus femoris also helps keep the knee in position with the other quads. So it takes all of that to make this. Pretty cool, eh?